So everybody has the brain. So the specialty of the brain organ is usually it does some analysis. Yes, guys. Yeah, if you have any doubts, if you are, already all these things, just tell me, let me know so that I can go to the advanced concept. Okay, just so what is the specialty of this brain is it does analysis because your brain has a complex network, the billions of the neurons, the complex network which is there in a human brain. What it does some analysis of data. Basically, if any data comes to the brain, it analyzes this data. Okay, so what is the advantage of this analysis? What is the advantage of this analysis? Is we can make the decisions, isn't it? We can make the analysis is, or the outcome of the analysis is the decisions. This everybody knows. Now, how can we use this? How can we use this analysis part? How it is relevant to the machine learning? What is the beauty of this is? Suppose if this is a person, you can assume that a doctor. So this is the person is a doctor. Assuming that he is an oncologist. So he is expertise in the cancer. Okay, the person. Okay, so the brain was filled with all the relevant stuff related to the cancer tissues or the treatments and so if any patient comes, if any patient comes to this doctor, because it's specialized in that. Okay, so he will say some X-rays. He will by looking at these X-rays, he will say the benign or malignant. Or I can say it's a positive, or it's a negative, positive, something like. So this what the doctor is doing here is a the patient comes. So with his brain, I can say his brain will analyze these X-rays because the brain is already have equipped with some knowledge. With his knowledge, he will make the decision about the current status of his cancer. It's a benign or malignant tissue or something like. He will take some decision, isn't it? Right. Now, what I'm trying to do, because this is, we are human beings, as a God-given gift for us, we are human beings. The God-given gift, we have the brain. The brain is given by the God, so we are analyzing capability. This analysis will provide the decisions, and these decisions are the solution to my problem. The problem, what I'm yes. So the problem I'm addressing over here is the disease diagnosis, I can say. The problem I'm addressing the disease diagnosis. It could be any disease diagnosis. So for to diagnose this disease, I'm consulting the doctor is making a decision. Now, whole idea of the machine learning is if I replace the doctor, if I replace with a piece of code, a program, the moment when the same chest X-rays are given to this, this program has to analyze and give the decisions like negative and positive. How beautiful it is. The whole idea of the AI, ML, or deep learning, whatever the stuff we are talking in nowadays is of the replacing this doctor brain with a piece of code. So this piece of code will take the input, the chest X-rays, read this, and this program will make the decision. That's it. So the program we are developing is called machine learning models. Machine learning models. Why it is called machine learning? Because where the program will run? In the computer, isn't it? The program will run not in the air, right? It will run in a computer, a digital computer. It's a piece of code, right? The program is a piece of code runs on a digital computer. What is the learning? So the program which I'm going to write here, which I'm calling as a machine learning model, which I'm calling as ML model, I can call it a program. So how I'm writing this machine learning model is, so when I read this data, chest X-rays, when I read X-rays, chest X-rays, whatever some X data, input image. So this model, you have to written a code, such that it has to start the learning. it has to start the learning. It has to start the learning. So this data should help us. So not only two images, so we will feed with the multiple patient images. So we will feed with the images of different patients, images of different patients. So this I'm calling as the data set. This I'm calling as a data set. So once I feed the data set to the program, I can say where this program will run. This program will run inside the computer, isn't it? This is in a computer, inside the computer with the help of the processor and all. Okay. So once this program is, but what is the beauty of the program here I'm talking is, this is not the normal program. This program will providing a facility called learning facility. It means that you are providing, with the help of this program, you are giving an artificial brain to your computer. Means now the computer is not only read the data, now it will analyze the data. So now this, when your computer is running with this kind of programs, so it has the capability of the analyze. So this computer will have analyzing capability, isn't it? That's what we are doing now, right? So if I'm, why it is called as, there are some technically supervised, unsupervised, semi-supervised. So why it is, this is called supervised learning. Why it is called supervised is to make you understand supervised learning. So let me take this some example. With that example, then with that analogy, I will try to map the what is happening exactly in the machine learning models. Okay, so let us. Okay, suppose this is the mother, and this is a baby girl or baby boy. This is a mother. Okay, so by birth, just born baby, she don't enter maybe after a couple of months. So what this mother will do, that she will show her the what I can say, that a book. I can say the book. This mother will show the book to this guy and ask the guy what it is, because she want to teach something to the student. So what it is. So this guy, he don't know anything. The baby boy, because he's just born, his brain is empty. You can say that his brain is empty. If the brain is empty, his brain is filled with it. Now, then in the next day, she will show the same book. Will not say, she will, mother says that it is a book. So after 5-6 days, what it will does, so when I am saying the same book, he will say some different object. So then suppose when the moment you said it's a book, when a moment and I say it is a book, when I show it after some days, the moment when I say it is a book, and I call it as a book, he might have said some different. Yes, can you?
Sir, please could you unmute yourself, sir?
Since how long I have been in mute?
Just now, sir.
Okay, thank God. Earlier, my voice was audible, right?
Yes, sir.
But I don't know how we suddenly enter into mute again
Okay.
now.
Okay.
Sorry, okay. Just
It's
be a. Thanks for bringing into my notice. Otherwise,
okay.
Yes. Yes. So what is happening here is, there's a baby and there is a mother. There's a baby and mother. And when mother is showing a book and is asking that, I cannot say it's not book, it will take relevant some object. Not book, I can say it is a pen. Okay, say it is a shown some pen. Okay, some pen, something pen. Okay. Then when I show to this pen, he cannot identify it's a pen, right? So after showing 2-3 times, he will say that it is a spoon. It is a spoon. Then the mother will say that no, it is not a spoon. It is the pen. The pen, something like that. So then after a couple of days again, when there is a mistake, so like this, when the person is making the mistakes, so either mother is correcting. So when the person is making the mistakes over here, the baby is mistake. So it's a mistake over here, mistake or error. Who is correcting? The mother is correcting that it is a pen. So then his brain will start learning. From these mistakes, his brain will start the learning. So after some days, when the mother has shown the a pen, it's a pen, something like this, then he will show, it will recognize a, when they show the pen, it will recognize a pen. So then the game is over. So what is happening in this process is, so we are trying to, the mother is trying to inculcate how an object like pen look like in the brain of the, what I can say, the child. So whenever you see the, because in his mind, even now, you can identify what is the features of the pen, how the pen look like. So you can now, if not only similar pen, if any pen, if you see, is try to identify, mostly it is in a pen, it is a spoon, or it is a book. But how the learning takes place. Learning means the storing of some information or the features of relevant objects in the brain. That is called learning. Okay, here. Why it is a supervised learning? Why I'm calling it's a supervised learning? Because the learning takes place with the help of a mother. Here, mother will act like a supervisor or instructor. What is the role of the supervisor or the instructor? Is to correct the mistakes. Is to correct the mistake. Everybody is agreed with this, okay? So this is a supervised learning, and the role of the supervisor is to correct the mistake. If the student do the mistake, the baby do the mistake, mother is there to correct the mistake. Through mistakes, the learning is taking place. So this is called a supervised learning. Now let us take the same supervised learning in the machine learning. The machine learning. So let us take this analogy into the machine learning. Now there is a model. I'm saying there's a machine learning model. ML model is nothing but a code, a piece of code. So what it does, it will first read the data. So this is my data set. Read the data. So read the data. Okay, so before I will proceed with this, let me take it. So instead of this, let me take one patient, okay? The one patient chest X-rays. X-ray, benign or malignant, okay? The patient one. So these are belong to patient, the patient one information, okay? Now, so when I'm reading this data, so what I'm trying, this model will say that, the model will say that it is a, the model will say that, what the model will say, it does some, gone. Sorry. Okay. Let me redraw. Sorry. Yes, this is a model. And when I'm reading the data of the particular patient, some X-ray image, it will say that is a positive. A positive. But you know that the patient P1 is the negative. You know, it's a negative. This is the ground truth. I can say the target, or I can say the class label. Class label. Class label. So when I'm comparing the positive and negative, when I compare the positive and negative, so there is a mistake. I can call it error. So to rectify this error, so what I'm trying to do, so we are doing some modifications. Inside the model. Then again, you are feeding this data until it properly classified. So what I'm trying to do over here is, I'm trying to make this model. When I'm making the modification means I'm changing I'm making the model to learn. The learning is taking place through these mistakes. There's a learning is taking place. So this is something like the analogy which I took just now. Who is, when you are coming to know that there is a mistake, when I compare with the ground truth, so like class label. So here the class label is nothing but acting like a supervisor. You agree? Here, so the class label is acting like the supervisor. Yes, supervisor. So that's why. So If I'm talking about any classification problem, are regression problems, in the regression problems. So these are called the supervised learning approaches. Means there is a ground truth. Means if I'm looking at the data set of these two problems, so the data set will have all the features, and along with all the features, it will have some ground truth information, or class label, or I can say output, or I can say the target or ground truth. So these are the features, set of features, and what is the corresponding outcome. Like, so these are the features of a diabetic patient, and if the following features are there, I can say is the diabetes positive. If the following features are there, I can say the diabetes negative. The following features values are there, so diabetes something like this, positive, negative, and all. Right. So if the output, the ground truth is a discrete outcome, the ground truth is a discrete outcome, the output you are predicting is a discrete value, then it is called a classification problem. If the output you are going to predict is a continuous value, like stock market prediction, where you are trying to predict the continuous value, like what is the stock price of a TCS or HDFC or SBI tomorrow. So what the stockbroker will say? The stockbroker will say that, so you are getting, so the 2300 or 2301, 2302, some value will give as an output. Okay. So whereas the predicted outcome is a continuous value, then it is called a regression problem. And when we are going to predict, your model is going to predict and a discrete outcome, then it is called a classification problem. So both these models is called supervised model, because of this ground truth, only the learning is taking place. The learning is taking place. That's what is supervised learning. Like studying in presence of a teacher. So we are, suppose today you are here, you are listening what I am trying to say. It's a supervised approach. So in the presence of the teacher, if you are learning, and if you are making any mistakes, there is like a instructor, a teacher is there to correct your mistakes, then your brain will start learning. So this kind of learning is called supervised learning. And if you are learning on your own without anyone else, whether making mistakes or not, nobody knows. When you are learning on your self-study, so that is called unsupervised learning. Okay, so we will talk about unsupervised learning maybe tomorrow, day after tomorrow. But for today's discussion, so I want to give the overview of what is the supervised models. So we have just now got a clarity about what is the classification problem. So the best example for the classification problem is the disease diagnosis. When a patient comes and there is a machine learning model, it has to say that whether this patient belongs to the positive group or it will belongs to negative. Means we are classifying this patient, whether he will belongs to positive group or the negative group of the people. Whether the patient symptoms is similar to the positive class group people or the negative class group. So we are classifying the given patient whether which category it belongs to. So this is the classification problem. Suppose the given the what I can say that this is diagnosis. The given an image, and based on this image, should I say that whether the particular patient is having the COVID or not? If I given the CT scan images, of a patient, lungs images, so you have to say that the COVID is positive or the negative. So by processing this image, your model, the classification model, okay, typically we will use the CNN and all this stuff, but I'm not discussing. So we can use any of the classification model to process these images, and at the end it has to classify. So these CT scan images are similar to the positive class people or the negative class. You have to classify that category or this category. Whether the student will get fail or pass, whether there is a rain tomorrow or not. Yes or no. So when your predicted outcome is the discrete outcome, so those kind of problems are called the classification problem. As we're talking about the regression problems, like weather forecasting. So if I ask if there's a machine learning model, so if I ask this machine learning model, what is the expected temperature tomorrow? What is the expected temperature tomorrow? So it will say that tomorrow expected is 27 degrees Celsius or 28 degrees Celsius or 27.1 degrees Celsius. It could be any value. It's a continuous value. There is any value is possible. So there exists any possible. So continuous value. 27 is possible. 27.1 is also possible. 27.12 is a possible. So when your predicted outcome is like this, a continuous prediction value, like stock market prediction. What is the expected stock price of TCS or HDFC or SBI? It will say 2701 rupees. It may say 2701.35. Any value is possible. Any value it will give it as an output. So this is kind of the continuous value you are trying to predict. The continuous values you are trying to predict. So these problems are the models. These problems are called regression problems. The model which are solving this problem is called the regressors. Whereas the earlier problem where the prediction outcome is what I can say is a discrete outcome, and the problems are called classification problems, and the models are called classifiers. Okay, so I think now you got some basic understanding about what are the different kind of what is the classification problem. To solve the classification problem, we have a classifier. To solve the regression problem, we have a regressor. So keeping unsupervised learning and semi-supervised learning aside, reinforcement learning. Now, so let us talk about what are the different kind of classification algorithms are possible. Classification algorithms are there. So when there is a problem, once you know that, first you have to identify there is a classification problem or regression problem. Once you identify that it's a classification problem, once you identify classification, what are the different kind of algorithms are possible? So classification problem, what are the different kind of classification algorithms are there in the literature? So if I'm going back to the literature, so there are the simplest, the classifier is called Navy-based classifier. And there is another classification algorithm is called the decision tree, the classifier. There is another classifier is called the support vector machine and the KNN classifier. There are neural network based classifiers. They are neural network based classifiers. So there are so many classification algorithms are there. So these are a few the classification algorithms. So coming to this, the regression algorithms. So the linear regression. So another classifier I want to mention is logistic regression. It's called LR classifier. Please remember, logistic regression is a classifier, not the regressor. Linear regression and the ridge regressor, polynomial regressor, regression algorithm. So depending on the complexity, there are different kind of regression algorithm. So try to remember that in the regression algorithm, the output you are predicting is the continuous quantity, whereas here it is in a discrete. Okay. So with this knowledge of the classification and regression algorithm, so let us see how the decision tree will be used. It's very simple to understand, and just it involves a lot of little mathematics. With this little mathematics, we can see how the decision tree, the tree-like structure, will help us in making the decisions to make us the decisions. Okay? Now let us see the decision tree algorithm. So if you're looking at a classification based, I think a supervised learning, it is called supervised. Unsupervised learning is a clustering. And in the classification, you are going to predict a discrete or categorical value as output. And whereas in the regression, you are trying to make the numeric predictions. Okay, whereas models with the continuous values predictions that predicts as a called regression problems. Okay? So yes. how do we construct the model? Okay, how do we make the model to learn? How do we make the model to learn? So this stuff, what are the stuff I am going through now? This has been taken from the H&K Camber book from his PPT. So it's a data mining book. There I took these PPTs for today discussion. Okay, how this model has been constructed. So for that purpose, what I'm trying to do that. So we are dividing a data set, as I mentioned somewhere in the data set, so into two parts. One is called training and other is testing. So training is the data set is used. And remember the training and testing data should be disjoint. There should not be a single sample which common across the. Okay, there is no. These are two disjoint data sets. There should not be a common sample should exist between these data sets. So if I divide the data set into training and testing, so the training data set is used to build the model, and the testing data set is used to evaluate the performance of the whether the model has built properly or not. The built model is working fine or not. Something like I will teach some concept in the class and I will evaluate your performance on the exams, how we are performing in the exams. So accordingly, I can change my mode of teaching and something like that. Okay. So that is we'll get some kind of feedback. So some similar lines, in the similar lines. So we are training the model by using training data set. So what will happen during the training? It will get some knowledge. You get some knowledge, and whether it has learned this knowledge I am tested with the help of the tested data set. So that's it.
Hi, sir. Good evening, sir.
Yes.
Am I audible, sir?
Yeah, you are audible. Yeah.
Sir, sorry to interrupt in between. Actually, sir, what things are actually required? Like what we have to select for training data set and test data set? And sir, how we can decide that this particular algorithm or model is suited for any kind of data set? Please elaborate something, sir.
Sure. Yes. Okay. So let me answer the learner's question. So yeah, let it be here only. So what I'm trying to do that. So there are some. This is my data set. So some of the samples I can say usually we will divide 70% of the sample. 70% of the samples. Suppose there is 1,000 samples. So these 1,000 samples, out of 1,000 samples, the 700 samples are used for the training data, and 30% of the samples are used for the testing of the model. This is standard practice. 70, but some people may go with the 80-20. But the question is, which 80 have to choose? Which I have to have? Suppose somebody has selected the first top 80, their performance different. If I choose the bottom 80, then the performance is different, isn't it? Because that depends on the number of things. So that's the reason. So there is an ambiguity over it because the way how you are going to choose these 70% or 80%. Usually it is a random. So obviously that leads the different kind of performance from the models. To overcome this problem in the research community, what we are going to do is we are going with an approach called tenfold cross validation. We are going with an approach called tenfold cross validation. So what is the tenfold cross validation? What we are going to do is your data set is being divided into 10 equal parts. 10 equal parts. Just yes. So sorry. Just let me wait. So what I'm going to do, this is my data set. So this data set is now partitioned into 10 equal parts. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this okay. I'm numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can say set 1, set 2, or you can give it. So what I'm going to do, this is my model. This is my model. Okay. Now what I'm going to do now in the tenfold cross validation is, so the test is, so this portion. So these are the 10 equal parts. Suppose this is having 1000 samples. It is having 1000 samples. 100 samples are here. 100 samples are here. 100, 100, and like so. Every partition is a 100 samples. Okay. So this is my test set data set, and these are all my training data sets. So this I'm calling as, suppose if I'm calling as a fold one, this I'm calling as a fold. In the fold one, the test is the samples in the partition one, the training data set is, except one, 2, 3, 4, and so on, 10. All this. In the fold two, the testing is the second data set, the second partition, except 2, 1, 3, 4, and blah blah up to 10. Like this, in the fold 10, so what are we? This the last portion as the test data set, and 1, 2 up to the 9 is the training. So what I'm going to do that, my model has been trained with 10 different combinations of the test and training. 10 different combination of the test and training. So what is happening in this process is this model. Now can you tell me that how many times the samples in the partition 1B is seen by the model?
10 times.
Exactly.
Sir, please could you unmute yourself, sir? Just now mute us.
Oh, I don't know why it is entering into the mute. Okay, so anyhow, okay, thank you for bringing it to my notice. Yes, if you looking carefully, observe here, the fold 2, in the fold 2, so this samples is in the training part. So it means that your model has seen. In the remaining all the cases, your model has been seen. The model has seen 9 times here. The model has been seen 9 times. And the testing, if you include and it has been tested the 1 time. So if I include both training and testing, so the samples in this has been repeated 10 times. So your model, I can say, roughly it has seen, not roughly, exactly your model has seen the 9 times. So this data has been seen by your model 9 times, and this data has been seen by your model 9 times, 9 times, 9 times, 9 times, 9 times. And tested by this, your model is tested with this sample as 1 time, 1 time, 1 time, 1 time, 1 time. There is no, if you look at this model has been, indirectly the model has been trained with a data set. Indirectly, I built a model with same number of samples, because this model has been, your model has seen this data 9 times, this 9 times, 9 times like this. So every sample has been seen by your model exactly the 9 times. So I am giving the equal importance to the every sample. So there is, because there is no scope for missing of any other sample, because your model has been trained with the all samples with the equally distributed. Okay, so with equal distribution, all sample have been seen. Your model has been trained with exactly 9 times by all the data samples, and tested by with all the data sample exactly once. Means we are training your model with all the samples and testing your model with all the sample indirectly. So this is called 10-fold cross-validation, and in this case 10-fold cross-validation. So what we will take, we will estimate the performance in the fold 1, we will estimate the performance in the fold 2 and fold 10. So at the last we will take the average performance. We will talk the average performance. We'll talk the average performance of the model. So this is a standard way to split your data set, because when you split your data set randomly, there is a chance that your data may be, some sample may seen by your model, some sample may not be seen by your model. Okay, but here if you are going with this, all the samples have been seen by your model exactly 9 times. If you 10-fold cross validation. Okay. So yes. The Jagat, am I answered your query, or still you are looking for anything else? I mean,
Yes,
what
sir.
is your-
Yes, sir. Yes, sir. Elaborate it. But sir, what parameters we have to select, sir, for a data set? Actually, those things are coming into my mind, sir. What things we have to consider for this model actually? Like what parameters we need to select in a data set? And
what
depending
uh,
how,
uh, what the
depending on
parameter?
how, yes, so please, sir.
What can you come again? Because there's no parameters I cannot say. I mean, so
Okay.
we can fine tune the model according to the data set. Okay. So because
Okay,
always
according to data set. Yes, sir. Yes, sir.
yes, because always we cannot have a data set of a desirable form.
Yes, sir. Yes. Sir.
So are you,
Yes, sir. Thank you,
are
sir.
you with
Thank you
me?
so much.
Okay. Okay.
Yes, sir. Thank you.
Yes. So yes, yeah, this is how we can usually do the model training in the research papers. Okay, in research. Yes, here we are. Yeah, yes. Now, once we build the model with the help of training data, so I just now mentioned that you can go with the 10 FCV, 10-fold cross validation, because there is no problem. If you go with 80, 20, 70, there is always you will select the 70% of sample randomly. So there is a chance of the every time you may select different set of samples. Now, once we this training data set, once you build the classifier, so this classifier is the tested with the unseen data set. What is the unseen data set? It's called your test data set. So the data set which is not being used during the training process is called test data set. So this test data set is called a unseen data set. So there you will make the predictions of the unseen data sets. Okay, predictions of the unseen data set. So if the name is Jeff and his rank is professor and the years of experience is 4, so can you tell me whether it's a tenured faculty or a permanent faculty, something like this? Okay? Now, what are the easiest algorithm to build such a easy classifier to do the predictions on this unseen data is called a decision tree. So let us spend some time on the decision tree algorithm. Okay. So let me explain about what is the decision tree. If you already know about the decision tree, please let me know so that I will discuss some other advanced topic. So guys, shall I discuss the decision tree or shall I go with some advanced concept? I mean, guys.
Yes, sir, you should, sir. Little bit.
Yes. If I'm talking about the decision tree classifier, so this is how the decision tree look like. This is how the decision tree look like. And here, this decision tree has been generated from this data set, the data set. So what is there in this data set? So there are 4 features, 1, 2, 3, 4. What are these 4 features? If the student age and the student income, whether is a studying or not, whether is a student or not, is currently studying or not, is the student status is S means is a student and studying in some course, and no means he is not studying. What is the credit rating? So means whether the credit rating is excellent or fair. So based on this, what I'm trying to find out, the decision I'm going to make the decision. The decision which I am going to make is whether he will purchase a computer or not. S means he will purchase a computer. No means he will not purchase it. And these are the 4 attributes. The 4 attributes. With the help of these 4 attributes, I am making the decision. Okay, this is about the data set. So this data set is having 14 samples. You can check it. This is having 14 samples. In this 14 samples, the how many are yes? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 are yes, and 5 are no sample. This is the distribution of the data. Yes. And another important thing you have to make a note over this particular data set is, so there are 3 categories of the ages. So there are some students whose age is less than or equal to 30. I am saying that all our age is less than or equal to 30. And if any student age is between 31 to 40, I am putting in the category of 31 to 40. If any student person is age is greater than 40, I am putting in the category of greater than 40 category. Similarly, if any, the based on income, have three categories of the people are there. So if the income is low, I am putting in the lower income group. If the income is medium, I am putting in the medium income group. And income is high, I am putting in the higher. So there are three categories. So there are three categories. There are three categories of the income people. There are three categories of based on age. There are two categories based on the student. There are two categories of the people, are there the student or not. There are two categories of the people based on the credit rating. So let's say it's excellent. Of course, there are two categories, the two decisions, yes or no in the class. So don't think that this is a feature. This is no longer a feature. This is a class attribute or decision variable. This is a big decision variable, or I can say it is the class attribute. So from this data set, so they have drawn this. I can say they induced or generated, I can say, generated this tree. So how they generated this tree, we will talk about in a few minutes. We will talk about in a few minutes how this tree has been generated. Now let's see some interesting facts about this decision tree. So why it is a tree? So in the real-time tree, the root is this first one, then there's the stem, there's the branches. This is the stem, the branches. So this is how a tree look like in the real time. So if I do invert, if I invert it, so this is something like this. So I can call this as a root. Okay, and these are the leaf nodes. This is a leaf node, and this is a leaf node.
On mute.
Again,
No, sir, we can listen your voice.
somebody said it's a mute, that's why I got confused. Yeah, this is the leaf node, and this is the leaf node. This is the leaf. So I can call these are the internal nodes. So this is the internal node, and this is the internal. Right. Now, if you're looking at the root and internal nodes, what are they? Basically, the root and internal nodes are the features. Age is a feature. Student is a feature. Credit rating is a feature. Of course, income is not there. Now, so what I can say that the root and internal nodes have the features, or I can say conditions and features. Strictly speaking, the conditions and the features, or features or condition and the feature. So what are the leaf nodes? What is the leaf node is containing? Yes, no. What is this S and no? The S and no is nothing but the decision variable. So what is decision variable? The decision variable or class attribute. So this is called decision node. The leaf node is also contained decision node. Decision node. What the decision node is containing? The class information. The class information means decision means yes or no. Yes or no. Okay. So if any new sample will come, it has to traverse from the root to the leaf. Suppose it has traversed from the root to the leaf. So it come to left branch, left, and then it has reached. If any sample is traversing in this direction, the decision is no. If any sample is traversing in this direction, the decision of that variable, that sample is S. If any sample is guiding or traversing in this direction, whose decision is S. Any sample is traversing in like this, no and S. So basically what we are trying to do that if I have a tree, I will traverse a tree from the root to the leaf node. So usually the leaf node will contain the decisions. So that decisions I am giving as the output. That's why this decision tree is called this tree is called a decision tree. So these decisions are at the leaf level. These decisions are at the leaf level. Please remember. So this is about something about a decision tree. So if I construct this decision tree, if I construct the decision tree, I can make the decision. Question is how to construct. How to construct a decision. That's all about. We will see now. Okay, how to construct this decision. So let me explain the how we can construct the decision. Okay. Now first you take whole data set. Take the whole data set. So there are features F1, F2, and so on, Fn, and this is the class attribute. This is the class attribute. Okay. So like a positive, negative, something. So what I'm trying to do that. So what is the internal node? The internal node for this is I am splitting based on some feature, based on the feature. So it could be f of I. I can say f of I. It could be f1, f2, f3, or f4, fn, and there are n features are there. I can choose any one of the based on the one features. Then I am splitting into sub data sets. Sub data sets. In sub data also, the last one is the class information, and this one also class information. Right. Next, again, so this data set, this original data set is D. Now I am partitioning D1 to the Dn, suppose. Okay. There are n possible n partition. Again, what I'm trying to do that again, I am further splitting based on the some features. Split based on some feature I. We do, which is not. So if this is F1, this should not be F1. Okay. That's that which is already not, which is not used already, which is already selected, we should not use. Okay. So based on the feature Fi, it could be different features. So this I can say is Fz. Fz. So then I'm splitting into sub data. I'm splitting. So identifying the splitting based on the features and feature. Then here is the class information, and this is the question is how long I have to continue with this partition. How long I have to continue this partition? So you have to continue this process until you create homogeneous partition. Until you create with the homogeneous partition. What is the homogeneous partition? In a homogeneous partition in which all the samples have same class information. All the sample will have the same class information. If all the samples will have the same class information, so that kind of partition I am calling as the homogeneous partition. So this process of the partitioning of the data set until you reach the homogeneous partition is called tree induction process, or I can say the tree induction algorithm. So this is called a tree induction algorithm. Right. The question is how to select the best splitting attribute, because there is f of I means it could be f1 or it could be f2 or it could be f3. There are fn. There are n possibilities are there. In this one, which one I should choose? Should I go with f1? Should I go with feature f2 or f3 and so on? So which one I have to choose over here? How to choose? How to select the best splitting attribute here? Here, how to select the best splitting attribute? Everywhere. So how to choose the best splitting attribute in the tree induction algorithm? There are three alternative ways are there. So there are different metrics to identify the best splitting attributes. So those metrics are called, I can say, those measures are called splitting measures. Splitting measures. So what are these splitting measures? The one is, those splitting measures are called information gain and the gain ratio and the Gini index. There are three splitting measures are used inside the tree induction algorithm. So if the combination of the information gained with the tree induction algorithm, then so that algorithm is called ID3. Means in the tree induction algorithm, if you are using the splitting measure as an information gain, then it is called as ID3. In the tree induction algorithm, if you are using the gain ratio as the splitting measure, then it is called C4.5. And the tree induction algorithm, which will use the Gini index as a splitting measure, it's called CART. The CART stands for the classification and the regression tree. So it means that so this particular the decision tree that can be used for both the classification and regression tasks. We will see how it is used for regression tasks once I will finish the classification. Right now, let's spend some time on let us debug what are all these formulas. Okay, so if what I'm trying to do, there is a tree induction algorithm. The tree induction algorithm just now in this tree induction algorithm we are splitting the data set based on the information gain ratio or gene index. Then accordingly we have different kind of algorithm. Three algorithms are there. Three tree induction algorithms. So depending on the what I can say what kind of splitting measure you are using inside. Now let us see how the formula look like about this information gain. So in the information gain, if you closely observe, so this is a formula of the entropy. So this is a formula of the entropy. So what we are trying to do that, how we are using this entropy. The entropy will give, the entropy. So here what I am trying to do is I am using the color. So what is the entropy? Suppose if I am using entropy. If I am using entropy for splitting, so how I am going to use this entropy? So what I have to do that, what is the entropy of my entropy? What is the entropy before partition? Please, this is the entropy of this. Let me draw over here. So, right. This is my original data set. And it has been partitioned. It has been partitioned into some data sets. So I can say it is a. I'm naming it as a the D1 and the D2, the DN. Okay. So this is a splitting based on entropy. How I'm doing is, so this is the entropy before partition, right? And what is this? How to calculate the entropy after partition? This is the entropy after partition. The entropy after partition, I can find out the entropy of this. I can say it is E1. The entropy of this, I can say the En. Every partition have entropies, and these entropies are multiplied with the corresponding branching factor. Means the summation of the branching factor of 8th partition and multiplied with the entropy of the 8th partition, where I is run from the 1 to n, where n is the number of partitions. So this will give the entropy after the partition. I know how to calculate the entropy for the partition. So the entropy before the partition minus entropy after the partition, if I subtract it, I will get the gain. How much gain in the entropy? What actually this entropy is giving? The entropy is giving the availability of the information. Means the information purity, or how pure is your data set. I can say if the data set is pure, I can say homogeneous partition. For the homogeneous partition, the entropy is 0. The entropy is 0 means it has a more purity. The entropy is 0 means more purity. Means the minimum the entropy, the maximum the purity. The minimum the entropy, the minimum the impurity. Minimum the impurity means maximum the purity. So basically the entropy will give the information available in the data set. The entropy is basically is giving the information available in the data set. So hence, what is the information available before the partition? What is the information available in the after the partition? If I subtract it, so that will give the what is the gain in the information? What is the gain in information availability? So that is called information gain. So the same concept I put in the formula. So what is this? The information the before partition. Everybody knows the entropy formula is Pi summation of minus summation of the Pi into log Pi. So the distribution, the probability distribution of one class is getting multiplied by its logarithmic value that is given by this entropy. What is this? So this is summation of where I is j equal to 1, where number of partitions, and this is the branching factor or weighing factor of the partition, and this is the entropy of the respective partition. So that is if I split with respect to A, if is a splitting attribute, if I split with respect to A, so this is the information available after the partition. Of course, this is by default before the partition, okay? So the gap, the before the partition minus the after the partition will give the what is the information gain. So usually the attribute A which results into the maximum gain is called is considered as the best splitting attribute. The attribute which is causing the maximum information gain is chosen as the best splitting. So we cannot choose the attribute randomly. So there is some systematic procedure that the attribute which is when I split with respect to that particular attribute, which is resulting into a partition such that so these partitions are giving the more information, or I can say that these partitions will try to give the more homogeneous partitions, because ultimately, so we are at the end we want to give the homogeneous partitions. So our aim is to create the more homogeneous partitions. So towards that, so what is the best splitting attribute? Okay, right. So this is how we can find out the best splitting attribute. Let's see one example. Okay, so let us take this data set, the same which you're already familiar with the particular data set. And if I'm looking at the class distribution, there are 14 samples are there. If I'm talking about the class distribution, so this is the class distribution. So there is a 9S, means there are 9 records in which the class label is S, and there are 5 records in which the class label is no. So this is the distribution of the class. So this is my data set D, and this is the data set D. The info of D means the entropy of the before partition is nothing but minus 9 by 14 into log of 9 by 14 minus 5 by 14 into log of 5 by 14. Minus 9 by 14 to log of 9 by 14. Minus 5 by 14, because minus pi into log pi, the same formula I expanded for 2 classes. So its value is 0.946. You can calculate, okay? So what it is? This is the information gain, info of D or entropy, the before partition. Now, let us find after the partition. But how we are partitioning? There are different possibilities, sir. I can partition with respect to age, or I can partition with respect to income, I can partition with respect to student, I can partition with respect to credit rate. So let us talk about what if I partition with age. Okay, so age is having 3 attributes, 3 categorical attributes. So one is the less than or equal 30, the other category is 31 to 40 and greater than 40. If at all, if I am splitting age into 3 branches, means 3 categorical values, means person whose age is less than or equal to 30 in the left branch, whose age between 31 to 40 I am putting in the middle partition, and whose age is greater than 40 I am putting in the right partition. If I do so, if I do like this, so what is the information available after the partition? If I split with respect to A, so what is the information available? That is called info of D with respect to age. info of D means what is the information available of the partitions if I'm partitioning age attribute into 3 partitions. Then how can you find what is the entropy of this? What is the entropy of this? Minus 2 by 5 into log 2 by 5 minus 3 by 5 into log 3 by 5. So the entropy of this has to be multiplied with the branching factor. What is the branching factor? There are 14 records are there. 5 plus 4, 9 and 9 plus 5, 14. So there are 14 records are there. After this 14, how many are there in this branch, left branch? 5. The branching factor is 5 by 14. So the 5 by 14 into entropy of the 5 by 14, the entropy of the left branch, entropy of the left branch. What is this? The 4 by 14 into the entropy of the middle branch. And what is this? The 5 by 14 into the entropy of the right branch. This is the entropy of this right. So when I calculate this, you will get 0.694. What is the gain? So 0.940 minus 0.694. I think 0.246 something like 249 or 241 something. Some value you will get it. 246 0.246 means, so if I split the data set with respect to age into 3 categories, 3 partitions. If I go with the 3 partitions, then the gain is 0.246. But the question is, if this is called a multivariate split, means the age is having a 3 categorical values, I am splitting into multiple partitions. So there is chance that I can split age into binary partitions also, binary parts like less than or equal to 30 and 31 to 40 into one category and greater than as 41. And less than or equal to 30 as one category and 31 to 40 and greater than 40 is another category. So less than or equal to 30 and greater than 40 as one category and other categories 31 to 40. So is there any other possibilities? No. So only there are 3 binary partitions are possible. Binary partitions are possible. Something like I will show here. Like this. So in the left branch, I am keeping all the records whose age is less than or equal to 30 and 31 to 40. In the right side, I am keeping the greater than 40. This is one binary partition. Here, so less than 30 and greater than 40 one category, 31 to 40 is another category. So 31 to 40 and greater than 40 is one category and less than or equal to 30 is one category. So there are total 3 possibilities are there. 3 binary partitions are possible. So including this, so there are 3 binary partitions are there. So for all possibilities, okay, there are so this is a multivariate split. This is a multivariate split. So this is a one multivariate split and 3 binary splits. Okay, 3 binary splits. For every split, you have a gain of age. So this is the gain of age if I go with the multivariate split. Similarly, gain of age and gain of age and the gain of age if you are going with the 3 binary split. For every thing you can calculate what is the gain. When compared with this, the gain of age, when I'm splitting the age into 3 partitions, only will result into the maximum. You can try at home, but even for those binary splittings, if you calculate the gain of age, still the gain of age with respect to this multivariate split will have the highest. Hence, as far as age is considered, the best splitting is the multivariate split, and it is resulting into the gain of 0.246. Similarly, I can do it for the what is the gain if I go with the income. So what is the gain if I go with the income? How many possibilities are there income? How many possible splittings are possible for income? How many possible splittings are possible? So income is having lower income, the middle income, and higher income. Okay, there are the low, medium, and high category of the people. So one multivariate split income you can split into low, medium, and high. This is one way splitting. The income you can split into low and medium and high as one category. It's a binary split. The income you can split high at one end, low and medium as another category. The income you can split the medium in the left, this is low and high as. So totally you have a, this is a multi-way split, one multi-way split, and this is the binary split, and this is the binary split, and this is the binary split. So three binary splits and one multi-way split. For every split, you calculate the gain. So which one is giving the maximum gain? So that is the best splitting as far as that particular attribute is considered. Similarly, you can calculate the, when I do so, for income, if you are going with the multi-way split, so that is giving the best results, maximum gain, that is 0.029. Similarly, student has only two categorical values, yes and no. So obviously you have only one binary partition is possible. Hence, what is the result of this binary partition is the gain. If I go with this binary partition, 0.151. So similarly, if I do for the credit rating, you will get 0.048. By apply the, how do you get 0.15 and 0.05? To get the entropy before the partition, what is the value? 0.940 minus the entropy after the partition or entropy of the split. How do you get it? Branching factor and has to multiply with the respective entropy of the partition, the respective entropy of the partition. So just multiply it for every partition, then you will get the, when sum it up, you will get the entropy after the partition. So then subtract from the 0.940, you will get the gain, information gain with respect to that particular feature. So among all, what is the maximum? So the 0.246. So this is the partition that represents the, if I split age into less than or equal to 30, 31 into 40 and greater than 40. If I split the age like this, you will have the maximum gain. Hence, age with this particular, the partition is considered as the first splitting attribute. So nothing but your root node, the root node. So that's the reason. So the first node is age, and I'm splitting age into three branches. I'm splitting the age into the three branches. So less than or equal to 30 in the left branch, and 31 to 40 in the right branch, middle branch, and greater than 40 in the. Now, if you surprisingly, if you see the middle branch, if you look at here, all the class information of this sample, the partition is same, S, 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 S. So this is a homogeneous partition. You can check it, the entropy. You can check entropy. The entropy is 0. You can check it at home. So entropy is 0 means the homogeneous partition. So the homogeneous partition means no further splitting, and once you create, so this node is replaced with a decision node. This is a leaf node called a decision node, and the label of this decision node is the class name of the all the sample. So S. What is the sample? S. So that's the reason. So you are replacing with the S. Now when I do the same process, if you carefully observe, so there is no age over here. So initially we have a 4 features in a data set. How many features are there? So 1, 2, 3, 4. Now,
Excuse me, sir, can I ask a question?
yes, madam.
Sir, if you have a binary split, the entropy would be less than multi-layer splitting?
Then you can go with that kind of splitting. So whichever splitting is giving the maximum gain, you have to go with that.
Okay. And sir, this data set is little small, so we are able to find the boundaries like less than 30, greater than. But if the data set is quite long, like a foot of 1,000 or lakhs of rows, then how we will decide the boundaries? Like,
I'm not getting what is my boundaries means.
Boundaries means the age you have taken, that it is split into 3 parts, like less than 30, then 31 to 40, and greater than 40.
Okay, that is okay. I understood your question.
Because from that data set we can see, but if you have a very large data set, how can we define those partition boundaries? Like,
so see, that is not the boundaries, I can say.
Huh.
So your problem, I will let me answer your question. So your problem will, whatever the problem you are talking about is, suppose it is a continuous attribute. If it's a continuous attribute, so whatever you are mentioning, that problem will arise. Whatever you're mentioning, that problem, but we have a solution for that. Don't worry, I will show soon. But what I'm referring in my data set, if you look at here, so if you looking carefully in this data set, so I am not making any boundaries. The something like, I can say this is a middle age, this is a middle age, this is a the teenage, this is a old age, something like this boundary is already given. So means there are, what I mean that here age is a categorical attribute. The categories are already defined. Means what are there are three categories are there. One category of people is less than or equal to 30, and other category of people is 31 to 40, and other category greater than 40. Or else you can say that the greater, instead of greater than 40, you can say old age, old. This is a, instead of this you can write it is a the middle age. This you can write as a young age, something like this. So already in the data set itself, this category is already given. I am not deciding the what is the boundaries of this. The less than or equal to 30, 31 to 40. I am not deciding. Just
Okay.
this category is already given in the data. How it has given high, medium, low.
Yes, yes.
So similar, of course, you are getting confused that the 31 to, you can write instead of 31 40, I can write the middle age. So greater than 40, I'm replacing as the old. Means this is old, this is middle age, something like this. You can replace. The data set itself already given. But your problem will arise when age is a continuous attribute. What does that mean? The age is continuous attribute. The age is something like this. This is 28, 29
Yes, sir.
years.
Yes, sir.
What? So yes, if suppose this is a 32 years, this is a 45, this is a 49, this is 50. So if age is continuous, how to do? The age is continuous, so then we have to do with this kind of approach. Yeah, this is the technique. If age is continuous attribute, what you have to do is, first you have to sort the age values. Suppose here I am sorting the income. Suppose then first you have to sort, and you have to take the average value of between the two successive values. So what is there? Suppose if I am here, I am talking about the income instead of age. If I am talking about income, okay, this is my income. Here income, how is the income is here? Income high, medium, low. It means that income is a categorical attribute, but income could be like this. This is 90,000, 60,000, 75,000, 85,000. Like if then it is a, if that is the case, income is called the continuous attribute. Income is called continuous attribute. If an attribute is continuous, first sort the values and take the average value between two successive values. Means first sort the values 60, 70, all are sorted order. Then take 60 plus 70 by 2, 65, 70 plus 70 by 2, 72.5, 72 or 73, 75 and 80 by 8 is 160, 80. Like this. So how many such how many such partitions will exist? There exist n partitions, or roughly n partitions will exist. So in that, the partition which resulting into the minimum entropy or minimum maximum gain, the partition which is resulting into the maximum gain or the maximum gain or minimum split, or I can say the maximum
Difference.
gain. Yes, the partition which is resulting, which is giving the maximum gain is chosen. In this case, for 97, if I split the income as a 97, means the people whose income is 97,000 in the left partition, the greater than 97 is the right partition. So that will create more homogeneous partitions. That is why you have to do. Okay.
Okay, sir. Okay, sir. Got it. Got it. Thank you, sir.
I think we have closed our session. Let me wind it up as soon as possible. Yes. So where we were, yeah. Let us repeat. If you look at this, the age. So after splitting with age, if you look at the left hand in all the partitions, there is no age attribute. You can carefully observe, because you're already filtering your data set with respect to age. There is no age attribute. That's why you have only initially you have 4 features. Now we are chosen one of the feature as a splitting attribute. So you have the data set left with the 3 features, 1, 2, 3, and class information. 1, 2, 3 class information. Now apply the same procedure. Partition this data set with respect to a splitting attribute. Now you have 3 splitting attributes with respect to income, with respect to student rate, with respect to credit rating. So you can identify the attribute which is giving the maximum gain. So when I repeat the same process in the left branch and the right branch, so what about the middle branch? Why I'm not applying the same process in the middle branch? Why?
It's homogeneous.
Yes, it is homogeneous, and you don't require any further partition because you already created a leaf node, decision node. Okay, something like this. There is no further partition. So that's why I applied the procedure on the left branch and right branch are non-homogeneous. Hence, I applied this procedure. After applying that, so once I select, the student will give the student, if I split the data set with respect student, you will have the maximum gain. Hence, the student will be selected for the left branch partition, and for the right partition, the credit rating will be used as a will if I split with credit rating. What I can say, credit rating as a splitting attribute, the right partition will have the maximum gain. Hence, the credit rating will be chosen. So after selecting the credit rating in the right branch, so it will create 2 homogeneous nodes. So one homogeneous node I am calling as a replacing the decision node with no and other one with S. Similarly here, I am creating 2 homogeneous nodes. The left is no and right is S. So like this, so we will construct the decision. Right. Okay. Now, so I think that's all about from my side. I think we have lost 9 minutes are there for queries. If you have any queries, please let me know.
Sir, I have a doubt.
Yes, always right.
You have a label yes or no. That is why you are splitting as a binary, right?
No.
Why you are doing binary? If I do it in other way, what will happen?
So we are talking about which attribute?
No. For multi-partition, further you have done it for binary, no?
No. This is a multi-partition, right? So if you look at here, age is split into multi-partition. Even if you do the binary, even if you do the age with the binary partition, so none of the binary partition will not give the maximum gain. So that's why I chosen. I told that is an assignment for you. You can compute it, and still the binary partitions of the age will not give the maximum gain, and the multi-way partition of the age is giving because age is having multiple categorical values. What is the category? One category is this, one category is this, one category is this. That's why you have a 4 possibilities, 1 multi-way partition and 3 binary partitions. Suppose if you're talking about what I mean that, okay, I will show somewhere. Yes, one sec. Student. If I'm talking about student, how many categories are there? Yes and no. Only 1 binary partition is possible. Only one partition is possible. One partition is possible. If I'm talking about credit rating, A and X, only 2 possible values are there. So only 1 binary partition is possible. That is one. I am not splitting binary. So if there is a multiple categorical values are there, I am checking all possibilities. So if I am putting it, let's see. Suppose I am talking about the income. So low, medium, and high income. So this is the binary partition. This one binary partition. This
Yes,
is one binary
here only I'm asked.
if you're looking at this is, I can say it is a multi-partition, multi-way partition. Among all, here this is not the gain. This is the Gini index. The different metric I have used. So don't look at these values. These values are different because these are Gini computed, not gain. Okay.
Okay.
If you compute the gains, you will get different values. So based on that, I can identify that. So this one is the not. This one is the This is the multiple split. This one is the best. This one is the best. So what I'm trying to do here is, so we are these four related to the income partition. So these 4 related to the age. This is related to the student status. This is related to the credit rating. So out of these 10 possible partitions for all features. So this income feature, age features, trade rating, and student status. The which one is having the least Gini value? According to Gini, we have to consider the least value. Okay. If it is talking about the gain, you have to consider the maximum value. So this is the least value. So hence, I am choosing that this is the best split. This is the best, something like that. You have to check all possible cases, all possible partitions. Yeah, Nityasri, yes, any doubts?
Hello, sir.
Yeah,
Thank
tell
you.
me.
Sir. Thank you, sir. Dear participants, any questions from your end?
No, sir.
Okay, thank you, sir. Vasanta madam,
So, how
are
to
you there?
decide we should go with the
Yes,
Bangalore
sir.
multi-
Yes, sir. Good evening,
Please
everyone.
put it.
Good evening, everyone. It is my privilege to extend our heartful gratitude to Dr. Ramalinga Swami, sir, for his enlightening talk on the fascinating topic of supervised learning techniques. Sir, your in-depth explanation of supervised learning applications, techniques like classification, regression, tenfold class validation, and clearly explained construction of decision trees with an example and splitting measures of induction algorithms like information gain with a deep explanation and example has truly engaging and informative. The practical examples and real world applications you shared have not only clarified complex concepts but also inspired us to explore this domain with a fresh perspective. I would like to thank you for taking the time to be with us today and for sharing your valuable insights. Thank you once again.
Yeah. So if you have any doubts, you can write a mail to rmlswamy@nitw.ac.in. So it is available in public domain. So you can have any if you have any queries, you can write a mail to me. Thank
Sir,
you.
I
And
have one question.
yeah.
Sir, I have one question.
Tell me.
Sir, what are the other things, means topics, if we want to see for data classification and we should look into? Means,
Means you are asking about what are the other classification algorithms? You mean that? Or-
just the names, so that which are most prominent one,
yes,
Excel
most
decision trees.
prominent and support vector machine
Okay,
and ANN based classifier like deep learning. Of course, if you understand like MLFFN, MLPN,
okay,
multi-layer neural network, and also logistic regression. Some ensemble based technique like random forest, bagging, boosting, and all this stuff. Those are nowadays ensemble learning is popular.
okay. Thank you, sir.
Okay. Thank you guys. Have a nice day. Good night. Bye.
Good night, sir. Thank you, sir.
Thank you, sir.